This is question 12 of section 1 of Natural Sciences Admissions Assessment Practice Paper 2017. And this is a question about bearings. So in this question we have a ship R, which is at a distance from a lighthouse L, which has bearing 220 degrees. We also have a canoe which is due north of R, and the canoe is the same distance from the ship and the lighthouse, and we want to find the bearing of the lighthouse from the canoe. So we definitely need to draw a diagram to see what's going on. So first of all, we have our lighthouse, and we've drawn on north as well so that we can work out the bearing. So we have the ship R is a bearing of 220 degrees from the lighthouse. So we start out on north and we go round clockwise 220 degrees, and that is where R is. So it's drawn on as such. We also have a canoe. The canoe is the same distance from the ship and the lighthouse, and it's due north of R. So it's going to be coming up due north of R here, and we have our north. So we form a triangle where these two purple sides must be of equal length because the canoe is equally far from the ship and the lighthouse. And the angle we want to find is the bearing of L from C. So we start at C and we want to find the angle to get to L. So this is this angle here, theta. We also know that these two sides are parallel because they're both pointing north. And we know some information about these two sides too. So what we know is that these two angles in fluorescent green here must add to 180 degrees because, as you can see, we've got a pair of parallel lines here, and we know that when we have a pair of parallel lines and this line between them, then these two angles must sum to 180. We also know that because we have a circle here that's 360 degrees, so the angle here is 140 degrees, it's just 360 minus the 220 we've already used there. And so, because they must add to 180, the angle at R must be 40 degrees. Okay, so now we have that this angle here is 40 degrees. So the next important piece of information we're going to use is the fact that this triangle is isosceles, which we know because we know that these two purple sides are equal. And what this tells us is that the angles here and here must also be equal. So if this angle is 40 degrees, this angle inside here must also be 40 degrees. And so we can find the angle inside the triangle at C, so this angle here. And we do that by doing 180, the total amount of angles in a triangle, minus the 240s for the other angles in the triangle. And so we get that this angle here is 100 degrees. Well, we know that this is a straight line, and the angles on a straight line add to 180 degrees. So from this, we know that theta must be 180, the whole line, minus the 100 here, so theta is 80 degrees. And that's how we get our answer of B.